All right, let's get started. Welcome to this session on making test-friendly microservices with DAPR. My name is Vidar Kongsli. I have been around for quite some years, as you can see. I live in Oslo. I work in a quite small Oslo-based software development consultancy called Bredvid. Please ask questions during the session. You can ask in English, in Swedish, in Norwegian. Danish might be pushing it, but you can try. So we are going to talk about software testing, and that's a topic that has been near and dear to my heart for some years. But when I talk about software testing, I mean automated testing, writing tests as code. And that has been around for a few years. Xunit, which was one of the first testing frameworks that became popular, was around 22 years ago. But still, I think we have a way to go when it comes to testing. So basically, I think that we might not have gotten the right tests yet. We are not testing for the right things. So this talk is a suggestion, a few thoughts about how we can arrange our tests in a better way. So we are also talking about DAPR. Mind you that it is not DAPR, the Object Relational Framework. It's the Distributed Application Runtime, which we'll get back to in a moment. Also, the third topic mentioned in the title of this talk is microservices. So what is the promise of microservices? What are microservices? Here are some of the things that we are supposed to get when we start creating microservices. Highly maintainable and testable, loosely coupled, independently deployable. These are things that does not come by themselves. We have to work at it. And of course, this talk will mainly focus on the first one, testable, maintainable, but also loosely coupled. So when I say automated testing, hopefully you all know what I mean. I mean writing tests in code, not the type of manual testing, not exploratory testing. Quite frankly, there is a lot of terminology around testing. I'm not too worried about the different distinctions about the terminology, but basically we're talking about writing tests. So this is also a category. This is a concept that you might have seen before, the testing pyramid. It categorizes tests into three categories: the unit tests, the integration test, and the UI tests. There are various versions of this, different categories. I'm not too rigorous about those. But for our purposes, when we talk about microservices, we don't really have a UI. So I would like to call them API tests, meaning that you test the microservice or the API from the outside. So unit tests would be tests very much from the inside. What is a unit? A unit is often a class. It's often a small set of classes, but often we test at the class level and even on the method level. Integration tests are tests where you put a lot of functionality together, group them together like a component or what have you, and do the testing on a set of functionalities rather than a simple unit. So the significance with the pyramid is that it tries to convey the number of tests that you need in each category. So according to this, you should have more unit tests than integration tests, more integration tests than API tests, and so on. But I would like to kind of challenge this view a little bit. How about we create a diamond instead, where we focus on the integration tests and have less unit tests? And of course, we can be even more crazy and say that I would like to focus on the API tests from the outside instead of the inside. So this might be a little bit provocative, but let's try to figure out how we can cater for this, how we can do this. So, but the problem is, or the challenge, I should say. What are the challenges with unit tests? What is my issues with unit tests? Well, they don't catch the problems in between. You can have a nice set of tests for your class, but you miss the interaction between the different components and the different classes. And it's often cumbersome to mimic or to implement a real condition for a class. It's not always obvious what are the real conditions that happen during runtime. You spend a lot of time simulating or mocking and stubbing the real environment, and the tests are also very brittle in terms of refactoring. So that when you refactor your code, you have to refactor your tests, they break, and so on and so forth. And also, I would argue that there are a number of unit tests that you can leave to the compiler. If you use a strong statically typed language like C#, F#, and so on, there are a lot of things that you would write a unit test for in a dynamic language that you don't have to write unit test or have to write tests for at all in a static type language if you arrange for it. So for instance, in the newer versions of C#, we are handling nulls in a very different manner than before. So you can keep nulls and null checking from your business logic. You don't have to do that if you arrange for it. You are guaranteed by the compiler that you won't have a null suddenly inside your code. And also, like parameter validation, when you test for a method, you have to validate that your input parameters are correct. If you use types for that, you can have less tests. And also there is a notion that you should have unit tests because they are quick. And I also kind of challenge that view that your test doesn't necessarily have to be super quick. At least that should not be a number one priority. So I propose that we, instead of focusing on unit tests, let API or integration tests be the norm and leave unit tests for the special cases. Of course, there are cases where you can have a unit tests. If you create type converters, for instance, you would like to test that type converter and for all the different situations and so on. So, very well, but how can we do this in practice? So, as you may or may not know, Microsoft ships a testing framework, which is an in-memory test server that you can use to spin up your ASP.NET applications in process when you do testing. So it's a separate NuGet package for it, and there's also a nice article on the Microsoft documentation website about how to get started with the integration tests. So here's an example of how this would look like. So there is an Xunit test. If you're familiar with the Xunit framework, it's kind of a similar to an MS test or N test or what have you. So here we are arranging our tests by creating an HTTP client. I'll get back to the factory method or the factory object later on. Then we act by sending an HTTP request, GET request to our application. And then we assert that we get a successful status code back. But the thing is that this call to the application never goes over the wire. It's a call made in process, although it doesn't look like it. So how do we arrange this? First, let's have a look at the program CS file for the application when it runs normally. And in this example, take notice of the entity framework DB context that we create. Here, in particular, we used the SQLite database to create our to store our information in entity framework. So let's say that we need to change this for our tests. So what we do then is that we create our own web application factory. Basically what that can do is that it can override the dependency injection container settings that we do in a normal run of the application. So here what we do here, this code will then execute right after the normal setup of the dependency injection container. We will search for a DB context object and remove it, and then we replace it with an in-memory database. There are good reasons for keeping SQLite in your tests. But this is for our demonstration purposes here. This is a change that we do to make our application easier to test in a test scenario. So we can then put this together by using this custom web application factory in our class definition. We then get an instance of this factory method as a parameter, as a constructor parameter. And this is the factory that we then use to create our HTTP client in the test. So let's have a short look at how this would look in the application. So just to give you an idea, first let's have a look at here's the program CS class with the DB context that uses SQLite. And then let's have a quick look at our test project. We have a helper class, which is the custom web application factory. And here's our replacement of the DB context. And we have our basic endpoint tests here that uses this custom web application factory. So hopefully this should pass. Yes, they do. Okay, so now we have done our basic test using the integration test framework, but there are some challenges to this. This is of course a very simplified application. One of the troubles that you run into typically are the dependencies that your applications have. So this is some random project application that I use. Typically there are tens of dependencies on NuGet packages. One thing is that you have to keep these up to date. Also, they create trouble for you when you are doing integration testing. So for instance, here we are using Azure Identity, we are using Microsoft Graph, we are using Twilio to send SMS, we have Entity Framework. These are integrations that are kind of opaque to us in the sense that we don't really know how this communication works. We don't have access to any of the details. So this will create a problem for us when we try to make our integration or API tests. So here is what DAPR comes into the picture. So how many of you have heard about DAPR before or used it? Not so many? Good. So basically, according to the documentation, it's an API for building portable and reliable microservices. So the basic concept, or the central concept here that I shall mention many times, is the sidecar pattern. So this is a motorcycle with an extra seat stitched onto it. It's called a sidecar. It's kind of quaint and very rare these days, but you might have seen one, or you may not. So in DAPR, a sidecar is a process that lives next to your application in your host. So if you have your application code to the left, you have this DAPR runtime here, which is called the sidecar. It then conveys the communication to other components, and the interaction in between your application code is either by using the HTTP protocol or the gRPC protocol. So this is a kind of a two-way communication. Your application code can kind of pull. It can call the sidecar to get something to happen, or it can wait for messages from the sidecar. So what we can do then, for instance, we can do service invocation. If application A or service A calls service B, it talks to the DAPR sidecar, which then conveys the information, communication, and adds things like name resolution, mutual TLS, encryption, and so on. You can do publish subscribe or pub sub. One application might send a message. Again, it calls out to the DAPR sidecar, which conveys this information using some infrastructure, in this case Redis. And then the sidecar at the other end receives the message and then delivers it to application B. The same for state management. We can also, instead of having a normal database or file system, you can talk to the DAPR sidecar for storing state. Again, calling the DAPR sidecar, a simple post request with some content gets stored into the database and also retrieved in the same manner. So there are a number of building blocks in DAPR. I won't go through all of them. We will have a look at 3 of those in my examples later on: state management, publish, subscribe, and bindings. So what does this mean for development? Well, first of all, you have a custom common API that you can look at for the integrations. And in terms of code, we can arrange a lot of this using the HTTP client pattern. I don't know if you know the HTTP client factory pattern that's in .NET. If you don't, I really recommend it. So during normal operations, there is an environment variable that your application can read in order to find the port that it needs for the communication with the DAPR sidecar. So in this case, I register an HTTP client named state, where I set the base address to localhost, the DAPR port, a version number, and which DAPR API I want to call. In this case, I call the state API. I also have a publish HTTP client, which calls the publish API. So having done that, my code, when I, for instance, trying to retrieve state or read from the database, what I can do then, I can ask the HTTP client factory for the HTTP client named state. Then I give it a store name and then a key into that store. And then I do a GET request to get the information. When I get that, it's all JSON, so I can deserialize it into my model. In the same manner, I can save state by posting to the store. I can publish a topic by getting the publish client, and then I post my model, serialize it into JSON, and that's it. And also, and this is a bit more interesting, I can subscribe to a topic. And using web API, this would be a normal controller where I have a certain path, and then I have my message data deserialized by the normal input bindings in ASP.NET. And then I can act on that message the way I want to do it. So we could have a brief look at the code, how that looks, what this looks like in code. Let's see. Let's go to the main application, for instance. No, sorry. Let's go to the admin application. Sorry, it's over here. This is the service where we talk to the state store, and we can, like we saw, we can get state from the database, and further down we can also save state by posting to it. And of course the HTTP client factory is injected into the constructor by the dependency injection container, and then we create our client, our state client instance here, so that we can call the state service. In a similar fashion, or not similar, but subscribing using an API controller, we receive the request. We deserialize the payload from the message automatically, and then we act on the message. Right. So now we have seen how we can do integration testing with the ASP.NET TestServer framework. We have seen how our code is changed using DAPR. So what does this mean for testing? This model, ports and adapters, is one way of looking at your code or structuring your code. It was invented like about 20 years ago by Alistair Coburn. You can go and read the article in his blog. But basically, it's an alternative to a layered view of your application code, where your business logic is in the core, and on the outside you have what's called ports, divided into input ports and output ports. And this is a generic way that you can communicate with your pure business logic. And then in a real application you have adapters. Primary or driving adapters is the situation where you get input into your business logic, like the app UI, like a console, and so on. And then on the outside, on the right side here, you have the secondary or the driven adapters, which, for instance, stores your business objects in a database, talks to a message queue, maybe you do HTTP, and so on. So this is relevant to testing in the sense that we can typically, if we create integration tests, we can kind of poke at the port of your application and then get rid of the real adapters that you would use runtime. So this is one approach. But an interesting observation here is that if we apply the DAPR pattern or architectural pattern to our adapters, we see that all the adapters becomes or could become HTTP based. So they are more transparent in terms of we can see what's going on. They are more comprehensive because they work in the same way. And I would say maybe that they are kind of trivial. So what we can do then is that we can test our entire application with this, with all the adapters and everything all at once. We don't have to test without the applications, without the adapters. So in that sense, we test the application in a more realistic environment or situation that we have runtime. So in order to show some code here, we need a silly demo application. It's not very useful, but this is an URL shortener. So if you know Bitly or the short links that you get, everyone needs their own. So I wrote my own so that I can, in a browser, I can enter a short URL. The application would return a 302 found, and then the long URL to the service that I'm trying to get to. So this has been architecture into 4 different services. It's the main service that the users will talk to. There's an administration part where I could add more short URLs. I can change them, I can remove them. There's a notifications service that in certain circumstances will send me an email. For instance, if a URL was requested that wasn't there, it can react on that and send me an email. And also there's a statistics component here which creates statistics on the accesses of the URL service. So it's not very exciting actually. But I can we can have a go at it. For instance, I could try to poke at it running on localhost. Here something wasn't found. I can go and talk to the admin. Sorry, I want it over there. I can talk to the admin interface, and then I could create this short URL, and then go back to the main application and try it again. And then it redirects me to Aftonbladet. Okay. So this is the application. Let's have a look at some tests. The first tests are on the core functionality, the redirections. So there we have to interact with the application here on the front, if you may, or if you will, where we can try to enter short URLs and look at the response. But in order to do that, we have to intersect the communication here with the state service. So we have to feed it some state so that it will work. So again, this is a test very similar to the one that I showed before. So here we are testing the short URL EX. We are testing the root of the application. We expect the EX to be found, and the root should return not found. Again, we use a client here, which we get from the factory. But then we have a method here before, initialize driven adapters. I'll get back to what that is. Remember that the so-called driven adapters were the ones on the right. You had driving adapters and driven adapters. This is kind of at the back of our application, if you will. We do some arrangements there. Then we act by sending requests to the application. Then we check that the status code is as expected. And then we do some verification of this driven adapters that I'll get back to. So, again, let's have a look at the custom web application factory. The last one you saw, we replaced the DB context. In this one, down here, is that we replace the original HTTP client factory implementation with our own. And this is a singleton class here in our container that will replace the behavior that's default in ASP.NET. So what's the HTTP client factory? HTTP client factory is over here. It's of type mock HTTP client factory that we should have a look at. Also notice a detail here. This fake HTTP client that we use to poke our application with or service with, we set it to not follow redirects. So if we did, we wouldn't be able to get the 3 or 2 result. It will just follow the redirect automatically. So that's important. So let's have a look into the mock HTTP client factory. Basically, what it has here is a dictionary of what is called a mock HTTP message handler. And the key in the dictionary is the name of the HTTP client. Remember that we have named clients. We had a state client and a publish client. And this way we keep a dictionary of those with those names. And when the application asks for a create client of a certain name, we look up in that dictionary the mock HTTP message handler, and then we create a separate HTTP client based on the mock message handler. This is all handled by an external library, but this is how we feed the application HTTP clients when it tries to reach out using the driven adapters. So what we then can do to initialize our driven adapters is that we can create message stubs in the state HTTP client, so that we tell the mock response handler what to do when it gets certain requests. For instance, if you get a GET request to HTTP localhost short URLs EX, it should respond by delivering some JSON, which we then read from an embedded resource in our test class. So here I've crafted a number of JSON files that I've inserted as embedded resources into my test project, and I can feed that to the application when it asks for data. Also, I have a fallback here. What will happen if there are no matches? I would like it to throw an exception so that I, as a developer, can go in and create all the mocks for the stubs for the right conditions. So this is a NuGet package over here, which basically gives you this mocking capability with HTTP client. You can also do mocking, stubbing, mocking, quite similar. A mock is where you can test for side effects so that you can actually test whether this was called or not after the test. In stubbing, you don't really care. You hand some information to the application. Don't worry about it. Here we are concerned with whether or not this call was made. So instead of using the when keyword, I use the expect keyword. I expect the call to be made, to be reached out for. And after the test is done, I verify that this expectation was met. So let's have another example. Let's have a look at the notification service. I can, let's see what happens when it receives a message on this topic, whether or not it sends an email as apart from that. So what we need here, we need to work with the interface between the DAPR sidecar and our application. So let's see. Here are some of the expectations that we make. Here we have a third HTTP client called bindings. We expect it to call a post or do a post to the email endpoint where some of the content or it contains short URL EX did not match. And then it will respond with status code OK. And like before, fallback is throwing an exception. And then in our code, we can, as before, create a factory. Then we create an event object, which we then post to the web API request endpoint, and which drives our test. We ensure a success status code, and then we verify the expectations on the binding that we're supposed to send an email. Right? So let's have a brief look at how this looks like again in the code. Let's see. We can do let's have a look at the notification. Sorry. Again, the notification controller receives the request from or receives the topic message or message on the topic. I'm sorry, and then it acts on it by sending a notification. So the tests would be something like this. Again, basically we get the bindings, we set the expectations, we create the client, we craft our message on the topic and then we post it, and then we ensure the return code and also the side effect that the tests should, or the notification service should have, in a sense that it should then use the binding HTTP client to send a message. So, good. Some tips and tricks. Oh, sorry, one more thing. Let's have a look at the test data that I use. So let's have a look here. Here I have let's do this one instead. Here I've crafted the responses that is that visible? Hopefully. Here I've created embedded resources which I have organized into test data, and then which HTTP client they belong to. These all belong to the state client, and they are just normal JSON responses that the application would get back, and then I read those. I set up stubs and mocks based on these information, these files. So tips and tricks: when your test suite gets larger, you can build up a catalog of these requests and responses. As you saw, I recommend using embedded resources for it. Also, use stubs and mocks intentionally. That where you use stubs where you do not care about the side effects, and use mocks to verify that side effects occurred when you poked at your application during a test. And also, this is good to inspect your DAPR, the DAPR API. There's a documentation page at dapr.io where you can see all the requests and responses for the different components, building blocks, sorry. And also, if you really want to have a look at what happens, you can use a tool like I did. The REST client in Visual Studio Code is very good to send HTTP requests with. You can use that and poke at your sidecar directly. And then in real life, you will see the request and responses. And then you can tune your code and you can tune your tests to act exactly like the sidecar does. So here you can basically run in your local environment, you can run the sidecar without your application. Just tell it which ports to listen to, and then you can interact with it directly. So good. So what have we really achieved? We got rid of some dependencies. NuGet dependencies. So here's typically the project. There is only one package reference, and that's not really related to our code anyway. We got a transparent and coherent communication with the outside world. It's all HTTP, HTTP client or web API, so it should be similar or familiar to whether you're talking to Microsoft Graph or Twilio, or you can arrange for it in a transparent way in terms of testing, at least. So we have lowered the bar for focusing on the API tests. If we have this kind of architecture, it's easier to have the upside down pyramid that I talked about. And we don't need as many unit tests. And of course, these tests are oblivious to the inner structure of your application. You're free to do any refactoring you want. You don't have to change the test. And also we kind of only scratch the surface. The same pattern goes for application configuration, application secrets, service-to-service invocations. Those are all building blocks in the DAPR tool belt that would follow the same pattern, if you will. So you can have an application that's only talks HTTP with the outside world, also considering things like application configuration and application secrets. So you truly can deploy your application to any DAPR enabled environment like Azure or AWS without changing anything in your application. So, do you have any questions? Yes? Right. The question was, how does this work when you have to consider security? So basically, my application was open to the outside world. Also, the parts that receive messages from public from the service bus. So I suppose that it kind of depends. Of course, you can have some sort of authentication where you, for instance, only allow for calls from the local host to be made to these parts of your API. You can test whether this call was local or not. I'm not sure. I'm not too whether I could assert the security behind that, but that's the way to do it. You can also say that your API listens to a different port than your public API, so that, for instance, you have another port number for your public APIs and keep these on a separate port, for instance, and then expose only one port to the outside. Because the DAPR container runs on the local host, it's not, so it shouldn't accept traffic from other hosts on the network. So good. I'll be available for the rest of the conference. I'll be here for the party tonight. If you have a question, do not hesitate. Also, this presentation and the sample code will be available here later on. So with that, thank you very much.